Hello students, I am Dr. Amit Bhatnagar, working as Senior Research Officer in the Department of Agronomy at GB Pant University of Agriculture and Technology, Pantnagar, Uttarakhand. Here in this lecture, I will tell you about the difference in layout of Factorial RBD and split plot design. So what is the basic difference and how we make the layout of Factorial RBD design and split plot design SPD. So there is a basic difference. So design is different, that's why layout is different. Analysis is also different. So you may watch the lecture on Factorial RBD and split plot design, which are in the playlist in statistics. So if you watch this lecture, then you can make a clear-cut idea about these two designs, and these two designs are frequently used. But we have to first make the layout of this design. So what is the basic difference in the layout and how we make the layout in the field? It is very important. So we will discuss and we will make the layout of these two design. Suppose there are two factor, nitrogen and variety, and we can test this variety and nitrogen in Factorial RBD as well as in split plot design. So suppose nitrogen levels are three nitrogen levels, for example 50 kg, 100 kg and 150 kg per hectare. Suppose these are three nitrogen level, and varieties are, suppose four varieties. We want to test four varieties, V1, V2, V3 and B4, and these are N1, N2 and N3. So we can check the effect of nitrogen and variety in Factorial RBD as well as in split plot design, but the most precise design is Factorial RBD. In case of split plot design, we make main plot and subplot, so precision is not as good as in case of Factorial RBD. तो हम इसको Factorial RBD में भी कर सकते हैं और स्प्लिट प्लॉट डिज़ाइन में भी कर सकते हैं, लेकिन जो प्रिसीजन होता है ज़्यादा वो Factorial RBD का होता है। SPD स्प्लिट प्लॉट डिज़ाइन का प्रिसीजन कम हो जाता है Factorial RBD से। तो क्यों हम ऐसा करते हैं कि SPD में करते हैं कि जब हमारा ट्रीटमेंट एग्जीक्यूट नहीं हो पाता है, व्हेन देयर इज अ प्रॉब्लम ऑफ एग्जीक्यूशन ऑफ ट्रीटमेंट इन स्मॉल प्लॉट्स, then we adopt split plot design. So some treatments require larger plot and other can be accommodated in small plot. That's why we go for split plot design. If treatment can be accommodated in split plot design, then we should go for Factorial RBD. तो हमको Factorial RBD में ही एक्सपेरिमेंट कंडक्ट करना चाहिए। अगर वो ट्रीटमेंट एग्जीक्यूट नहीं हो पा रहा है, उसके लिए बड़े प्लॉट चाहिए, तब हमको स्प्लिट प्लॉट डिजाइन में जाना चाहिए, अदरवाइज हमको Factorial RBD ही यूज करनी चाहिए। Factorial RBD is more precise than split plot design. So this experiment can be conducted in both design, Factorial RBD as well as in split plot design. Suppose we are adopting Factorial randomized block design, then what would be the layout? So number one, look the treatment. There are two type factors, nitrogen and variety. So first make the combination of treatment, that is 4 into 3, 3 into 4 means 12 treatments are there. Then make combination of these treatments, and we can write these combination as T3, T4, T5, T6, T7, T8, T9, T10, T11, T12. So how we make the combination? तो हमको क्या करना पड़ेंगे, जो तीन ट्रीटमेंट ये हैं, चार ट्रीटमेंट ये हैं, 12 ट्रीटमेंट, इनके हमें कॉम्बिनेशन बनाने होंगे। तो कैसे बनाएंगे? फर्स्ट हम लेंगे N1 के साथ, N1 लेवल, ओके, B1 भी ले सकते हैं इनिशियली हम, ऐसा कुछ नहीं है, हम नाइट्रोजन के साथ भी ले सकते हैं, पहले वैरायटी को ले सकते हैं, कोई इसमें दिक्कत नहीं है क्योंकि कॉम्बिनेशन बनते हैं, तो उसमें कोई ऐसे प्रॉब्लम नहीं कि हम किसको लें। हम पहले नाइट्रोजन को ले लेते हैं, इसमें कोई प्रॉब्लम नहीं है। तो N1, then B1, then we will make all the varieties with the N1. तो N1, B2, N1, B3 and N1, B4. then with the N2, N2 B1, N2 B2, N2 B3 and N2 B4. Now with N3, so B1, N3 V2, N3 V3 and N3 B4. So these are different combination, and we make combination with the first taking variety like B1 N1, B1 N2, B1 N3, then V2 N1, B2 N2, V2 N3, then V3 N1, V3 N2, V3 N3 and lastly V4 N1, B4 N2, B4 N3. तो उसमें कोई प्रॉब्लम नहीं है, किसी भी तरह से बना सकते हैं, हमने इसको इस तरह से बनाया. It means there are 12 treatments and these are T1, T2, T3, T4 like that. Now make the layout in the field replication wise 3 replication. So now it depends upon how to make the replication, depends upon the plot or the field area or field shape. So we require 12 plots. So 12 plots may be in the shape like that. We can make 12 plots in this manner: 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then, but this is not the good way. Okay, so this is suppose replication 1, then 12 plots like that. Replication 2, then suppose we want to keep replication 3 replication, then this way. This is replication 3 and we can keep replication 4, but in general we keep replication 3. Now allot the treatment randomly in this plot, okay, in this replication. So random number table is used for allocation of treatment. For randomization we use random number table. तो randomization हम करेंगे T1 से लेके T12 का करेंगे, उसके लिए random number table होती है, उसका यूज करते हैं. अगर random number table नहीं है तो हम एक पर्ची डाल के लॉटरी सिस्टम से अलॉट कर सकते हैं. यहाँ देखिए मैं randomly कैसे कर रहा हूँ इसको. सपोज T1, T2, T3, T4, T5, T6, T7, T8, T9, T10, T11. एक इसमें कम हो रहा है इसमें प्लॉट. सो दिस इज T12. Similarly in this T1, T2, T3, T4, T5, T6, T7, T8, T9, T10. इसमें 2 प्लॉट कम हो रहे हैं तो उसको हम ऐसे ले सकते हैं. T11 and T12. So this is the randomization of treatment. So in this way we can make the plot. Otherwise we can make the plot into a block of 3:4 or 6:2. So 12 treatments are there. So we can make 12:1. जो भी मैंने बनाया that was 12:1, or 12 is equal to 6:2 or 12 is equal to 3:4. So in case of 12:1, the 12 plots are made in this way. Then this is R1, 12 plots. In case of 2:6, 6 plot, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and this 12 plots. So this is R1. Now treatments are allocated as T1, T2, T3, T4, T5, T6, T7, T8, T9, T10, T11, T12. Otherwise the block may be 3:4 like that. This is only R1. Then similarly R2, 2 into 6, R2 plots are made. Suppose it is 3:4. Then 3:4, maybe a 1, 2, 3, 4, then in this way. Then we can allocate the treatment. T1, T2, T3, T4, T5, T6, T7, T8, T9, T10, T11, T12, maybe like that. Or maybe 4:3 means 4 in this way and 3, 4 this way and 3 this way. Maybe suppose हम इसको ऐसे भी लिख सकते हैं 3:4, then we can make 3 in this way and 4 in this way. Now there are 12 plots we can allocate randomly: T1, T2, T3, T4. Use random number table: T5, T6, T7, T8, T9, T10, T11 and T12. So this is R1. So the best plot mean size is 12:1, maybe 6:2, 3:4. If replication is compact, then it is more precise, means variability will be less. So if choice is there, then we should use this type of plot where plot is compact. Here plot is compact. Here it is very long plot. A long plot divided into 2 strips. If plot is compact, means their number difference is less. Then it is very good block or replication. So this is first replication, make second replication. But the choice depends upon the shape of the field. What is the shape of the field? If shape is long, then this is the choice. And if shape is good, then we can make 3:4 block. So the block should be compact. Compact means the difference between these two number should be minimum. तो ये हमको ऐसा ब्लॉक बनाना है जो compact हो, और compact ब्लॉक तभी होगा जब इन दोनों के नंबर के बीच का डिफरेंस कम होगा. यहाँ देखिए 6 और 2 का 3 टाइम्स जा रहा है, ये 12 टाइम्स जा रहा है. तो लॉन्ग होगा तो वेरिएबिलिटी इज मोर, हियर वेरिएबिलिटी इज लेस. तो ये दिस इज द लेआउट ऑफ फैक्टोरियल आरबीडी. बट if we want to check, we cannot manage the nitrogen. If nitrogen loss is more, leaching is less, leaching is more, or movement of nitrogen is more, then nitrogen cannot be managed in small plots. So that's why we have to make the large plot for nitrogen. In such case, a split plot design is used. So what is the layout of a split plot design? The same treatment, nitrogen 3 level, 50, 100 and 150 kg nitrogen. This is N1, this is N2, this is N3, and varieties are 4: B1, B2, B3 and B4. Now treatments, total treatments are 3:4. 3:4, that is 12 treatments. The same treatments are same, levels are same, but now we have to change the design. If nitrogen is not managed in small plots, because in Factorial RBD every plot is of equal size, but here in split plot some plots are large, that is main plot, and some plots are small, that is subplot. So if nitrogen is not managed in small plot, means there is a leaching or runoff of water, then we should make large plot for nitrogen. So there is large requirement of plots. That's why we can shift the design to split plot design. So now we have to keep the nitrogen in large plot. So means large plot, it requires large plots. It is known as main plot, and it accommodated into a small plot. So it is known as subplot, or main plot factor or subplot factor. We can say it is main factor, it is subplot factor. In main plot factor, we keep those treatment which require large plot size because they cannot be managed. For example, tillage, irrigation, they require large plot size. हैरो करने के लिए लार्ज प्लॉट चाहिए, इरिगेशन के लार्ज प्लॉट चाहिए, क्योंकि हम जैसे इरिगेशन करेंगे दूसरे प्लॉट में सीपेज से पानी चला जाएगा या रन ऑफ से चला जाएगा. Similarly, if there is a runoff loss of nitrogen through runoff water or any other problem, then we have to manage nitrogen in large plot. In such case, in first replication, first divide the plot in 3 equal parts. 3 equal parts. This is replication 1. This is replication 1. 3 equal plots, and randomly assign the nitrogen. Suppose this is nitrogen N1. This is nitrogen N2. Then it is nitrogen N3. So we will provide the nitrogen N2, N1, N3 in whole strip. This is the large plot. Then divide this plot equal into 4 parts, like 1, 3. So in all plots it is N2. This is N1, N1, N1. This is N2, 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 N2. This is N3, N3, and N3. Now, this whole plot, this whole 4 plot will receive same amount of nitrogen, that is N2. Then these all 4 will receive same amount N1, and similarly all these 4 equal amount of nitrogen, that is N3. Now in this is main plot, and these are subplot. Now randomly assign V1, V2, V3 in this plot. इसको randomly assign करते हैं. Suppose V1, V2, B3 and B4. Similarly here B1, B2, B3 and B4. Similarly B1, B2, B3 and B4. So this is replication 1. Now we can compare with the factorial RBD. In case of factorial RBD, we make treatment combination T1 to T12 and randomly assign T1 to T12. But here the particular this strip receives same amount of nitrogen, here another amount of nitrogen. So this is the split plot design. So in this case of treatment, these are the main plot. This is another main plot. This is the third main plot. So here main plot and subplots are there, and main plot have same treatment or same level, that is N1 or N2 or N3. While in case of factorial RBD, any plot can receive any treatment. तो ये एक डिफरेंस है factorial RBD और स्प्लिट प्लॉट डिजाइन का, कि factorial RBD में कहीं भी किसी भी जगह पे कोई सा भी ट्रीटमेंट आ सकता है, लेकिन इस स्ट्रिप में केवल N2 वाले ही आएंगे, इसमें केवल N1 वाले ही आएंगे, इसमें केवल N3 ही वाले आएंगे. So this is the layout of split plot design. If suppose plot is long, so in such case, suppose there are long plot, this strip is there, strip wise, and it is R1. So make 12 plots, 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Then we want to keep main plot in nitrogen, and nitrogen levels are 3. Then 1, 2, 3, 4 in 4 plot. This is the one main plot. This is 1, 2, 3, 4. This is another main plot, and this is the another main plot of subplot 4, 4. Subplot are 4. So that's why we will make a main plot in such a way that there are 4 plots. क्योंकि हमें कहाँ रखना है, 4 plots को सब में रखना है. Now randomly assign. Suppose it is N1, it is N2, this is N3. Okay, so it will keep N2, 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 N2. Here N1, 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 N1. Here N3, N3, N3 and N3. Now this is the block main plot. So not block, this is the main plot of N2, will receive same amount of nitrogen. Then randomly assign variety B1, B2, B3, B1, B2, B3 and B4. Namely B1, B2, B3 and B4. B1, B2, B3 and B4. So this is the layout. So this is the long strip, but we should keep compact plot size, that is possible into 3:4. Suppose you want to keep 2 into 6 2 into 6, then it is not possible in 2 into 6 in split plot design, because we have to make a combination of 4 plot. That is not possible in 2 into 6. Suppose we make 2 into 6 like that, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, and this is the 12 plots, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, we have to make the 4 plot. Then this can be randomized, but there is a little bit confusion. So now in this way, we have to make a combination on 4 plot. Then this is the 4 plot, first, second, and third. So now this main plot will keep n1, will keep n2, and this will keep n4. But this is not a good method, and better is 3:4 to make a compact block. So earlier that it is not also good, because it is long strip, it is also long strip. So the better is to make a 3:4. 3:4. 3 is like that, or 3 like that. Okay, so this is the difference between factorial RBD and split plot design. The basic difference is that, suppose यहाँ में factorial RBD देना होता, 12 plots हैं, T1, T2, T3, T4, T5, we can assign T1 to T12 in any plot. But in split plot design, we have to make a block of 4 subplot, then assign the first main plot, then subplot. So this is the difference in layout of स्प्लिट प्लॉट डिजाइन एंड फैक्टोरियल आरबीडी. तो ये मुझे उम्मीद है कि आपको ये शायद समझ में आ गया होगा कि कैसे लेआउट बनेगा, और लेआउट के लिए हमें ब्लॉक बनाने चाहिए, जो ये प्लॉट बनाना चाहिए, कॉम्पैक्ट बनाना चाहिए. तो यहाँ देखिए 12 का कॉम्पैक्ट 3:4 है, 3:4 में ये ज़्यादा अच्छा होगा, इसमें वेरिएबिलिटी कम होगी. सो दिस वाज द डिफरेंस इन लेआउट ऑफ फैक्टोरियल आरबीडी एंड स्प्लिट प्लॉट डिजाइन. देखिए लॉन्ग नैरो पे जा रहा है, ये लेआउट सही नहीं है. अगर हम इसको 3:4 में लेते तब इसमें वेरिएबिलिटी कम आती, तो ज़्यादा लेआउट अच्छा होता. तो 2:6 वाला भी सही नहीं रहेगा, 3:4 वाला ही हमें बनाना चाहिए, चाहे फैक्टोरियल आरबीडी हो चाहे split plot design. So now it is a difference in factorial RBD that 12 plots, any plot can receive any treatment T1 to T12. But in case of split plot design, the main plot, first main plots are assigned, then subplot are assigned. So that's why precision is lost, because this N2 is not here. So randomization is N2 is not here. So that's why precision is somewhat lost. So इसी कारण से स्प्लिट प्लॉट डिजाइन का प्रिसीजन कुछ कम हो जाता है फैक्टोरियल आरबीडी के कंपेयर में. सो दिस वाज द डिफरेंस इन लेआउट ऑफ फैक्टोरियल आरबीडी एंड स्प्लिट प्लॉट डिजाइन. थैंक यू वेरी मच.